Hello and welcome back to Factoring the Difference of Squares, a lesson from mathforbreakfast.com. In this case, we're looking at part 2. Part 2 on factoring the difference of squares. You're not learning anything new here. This isn't a whole new set of instructions on how to do this. It's basically another example. Example 2. Now, what I have here is the square pattern, which is what you've learned in part 1, which I so cleverly ended with, so let's crank it on. Not really sure what that meant. Again, in my world, just keep it quiet. And in your world out there, really quiet. Again, another thing to keep quiet is calling this formula, this pattern that we learned in part 1, I call it the square pattern. I'm putting quotes around that because, again, if you go say to someone, I know how to factor that using the square pattern, they might think the square is you. So you just, okay, just no talky about that. Just move on. But in your world and my world, we're using the square pattern, which is if you see something squared minus something squared, you can factor it. Split it into two things that multiply. Something times something. Alright? And in this case, the something times something are an a minus b and an a plus b. The unsquared thing minus unsquared thing times unsquared thing plus unsquared thing. Minus, plus, always a minus plus, a binomial times a binomial. Let's just see what that means with another example here. Factor. Okay, factor. We know factoring means split it into something times something. Alright, we've got that, seen it many times in these lessons. But we have to figure out what type of factoring is it, or what technique to use. And we do that by step 0. Step 0 at mathforbreakfast.com. Again, I always keep saying that because that's the only website I have. So that's where you would go to learn about reading, okay, about the read and look technique. Read the instruction, factor. Look at the problem. Well, let's see what I've got here. What I've got here is a square. I know I have a square because 64 is a square number. We have to just memorize that. I know this is a square. The m to the 6 is a square because that's even. Alright? Now again, this whole thing is a square because 25 is another square, 5 times 5. And then this again is even. So that gives me the knowledge that n to the 14th is a square as well. Finally, I have a minus here, and minus means difference. So I have square, difference, square. Square minus square, the difference of squares. That's what I learned from looking at the problem. So since I learned I have the difference of squares, I know I want to use the square pattern. Alright, again, quotes around the square pattern because we're trying not to get ourselves embarrassed more than normal in public. Alright, so I've got it. So step 1 is to fall on my knee there. Step 1 is to split the squares. I'm abbreviating obviously with SQ for squared. So 64m to the 6th minus 25n to the 14th. I'm going to split this over here. Well, 64 splits up into 8 times an 8. Notice I left a little space here because I have to split the m as well, and that becomes m to the 3rd and m to the 3rd. Alright? This 6 splits up into 3 plus 3, right? And this 14 splits up into 7 plus 7, and that's where I get these exponents when I split the rest of this. 25n to the 4th is 5 times 5. Again, I left a little space because I want n to the 7th. There it is, one of those 7s, times n to the 7th. Alright? I did my splitting. That's why I have to have even exponents here. So I can split it up into 3 plus 3, 7 plus 11, whatever the two numbers may be. And I know I did it right because 8 times 8 is 64. M to the 3rd times n to the 3rd, add up the exponents, gives me m to the 6th. And the same thing over here. So this is my split on 25 n to the 14th. Alright, finally, step 2. I love it. It's only 2 steps to glory and closure on these factoring problems. And that is use, let me get that right, use the square pattern. Exclamation point, because you're excited, I'm excited, mostly I'm excited, probably pretty much by myself. But I'm okay with that. Let's see how we use the square pattern. When I do that, I have 64 m to the 6th minus 25 n to the 14th is equal to binomial times binomial. One's a minus, one's a plus, and I need to just fill in these things. I'm going to give myself a little more room here. Forgot, these are a little bit bigger terms I need to use. So I'm going to rewrite the whole process in this one line here. I know I had step 1 split, step 2 use pattern, but you would kind of do it more like this. You would just start splitting this over here. 8m to the 3rd times 8m to the 3rd. And you split this into 5n to the 7th times 5n to the 7th. All right, well done. And now we take this first guy and put it here. 8m to the 3rd. This guy does not want to be left alone, so it goes in the front of the next binomial. 8m to the 3rd. Notice, this term, the 64, was the first one in the binomial. So these two factors of 64m to the 6th are the first terms in each of the two new binomials. So nobody gets left out. Here we go. Now this is the 5n to the 7th, and over here another 5n to the 7th. We split each of the squares. We use our pattern of binomial with a minus, binomial with a plus. Redistribute all the pieces. Again, you have to redistribute all of them because they came from the original problem. We can't just lose one. All right? That just wouldn't work. Factoring is taking something and changing the shape of it, turning it into a multiplied expression. But we don't change the value of it, just the way it looks. And so I don't want to lose any of these terms. So I put them all there. I've captured them all. And the final answer, again, as you know, is captured when we put the magic box around it. So 8m to the 3rd plus 5n to the 7th, and a big box all around that to make a big applause for your success. Mine too. We've done it. That's probably as sophisticated as they get. There are a few tricks they might throw into problems here and there, but I just wanted to point out this is factoring the difference of squares. Now, a little side note over here. Okay, let's say I have a problem similar to part 1. I had 16 plus y to, I think I had the 10th, something like that. All right, and you say factor. All right, this is a plus, P-L-U-S. Plus, the blue is right there. Let me try that again. It is a plus. All right, once it's a plus is not a difference. If it's not a difference, it's not a done. Okay, you don't do this problem. You stop. Stop. Done. All right, fine. Because it's a plus. Even though this is a perfect square, 16, 4 times 4, y to the 10th, perfect square, y to the 5th, times y to the 5th. Once there's a plus in between them, bam, you can't do anything except possibly factor out a common monomial. All right? One other thing to point out, with all of these problems, I have a square minus square, but that's only after I've probably factored out a common monomial. So again, always remember to look for a common monomial. But I'm giving you this lesson based on the fact you've already done that, and now you're left with this square minus square. You follow the process using the square pattern, and you succeed. You can do it. I did it. Replay this lesson over and over as you need to make sure you nail it and pass the exam, succeed on the homework, whatever it may be. I'm here for you. Again, if you go to mathforbreakfast.com, my premise, my mission statement is help you learn math.